Question 3. A pie is taken from a hot oven and put on a table. The internal temperature of the pie at time t minutes can be modeled by the function h that satisfies the differential equation dh dt equals -1/15 times the quantity h minus 20, where h of t is measured in degrees Celsius and h of 0 is 75. For t is greater than 0, it is known that 20 is less than h of t, which is less than 75. Now in part A, they tell us, explain why the following could not be a slope field for this differential equation. Now that's based on this piece of given information right here, is that they give us that 20 is less than or equal to h of t, which is less than or equal to 75. So because of that, we know that h minus 20 is going to be greater than 0. It can be anything, but we know that it's going to be positive. And so therefore, because we know that that is positive, and we're multiplying by -1/15, that means dh dt must be less than 0. However, but the slope field shows that dh dt is positive for all these values of h. So this shows dh dt is greater than 0 for 20 is less than h, which is less than 75. So that's why that doesn't work. All the slopes in here should be negative. Now part B says find the slope of the line tangent to the graph of h at time t equals 0. Now based on the given information, when t equals 0, h equals 75. And we need that when we plug in to our differential equation. Because we can't plug in t, there's no place to plug in t, but we can plug in 75 in for h. So when we plug in 75, what we get is -1/15 times 55. Now if we cancel out a 5, that's 1/3 times 11. So that gives us -11/3 for our slope. So using the point h of 0 equals 75, in point slope form, this is going to be y minus 75 equals -11/3 times x minus 0. And usually they like to have y by itself, so that's -11/3x plus 75. Now it's quite possible that they may want you to define this in terms of t and y. That is quite possible. So, but I don't think they're going to make that big of a deal about having x instead of t. Part C. It can be shown that the second derivative equals 1/225 times h minus 20. The line tangent to the graph of h at time 0 is used to approximate h of 5, the internal temperature of the pie at time t equals 5. Is this an approximation, an overestimate, or an underestimate for the actual value of h of 5? So we're asked, is this an over or underestimate? And so what we're asked to do is to use this given information. So what we're asked to do is to use the second derivative test. And so we need to find what is the second derivative based off the tangent line at the point that we used. So we have to go back to, at time t equals 0, h is 75. So we're going to plug in h equals 75 into our second derivative. And in so doing, we get 55/225, but the more important issue is that this is greater than 0. So what this tells us is that at time t equals 0, h of t is concave up. Therefore, the approximation of h of 5, and we don't need to say using the tangent line because we already know that we got that approximation using the tangent line. That approximation is an underestimate. And so we know that it's concave up because when we plugged in 75 for the second derivative, we got a number that's greater than 0. What the actual number is isn't as important as the fact that it was greater than 0. Part D. Use the separation of variables to find an expression for h of t, the particular solution to the differential equation. So taking dh dt equals negative 1 over 15 times the quantity h minus 20. First, we're going to separate and get everything with h on the left. So 1 over h minus 20 dh equals negative 1 over 15 dt. So that's step 1. Once we've done that, we can integrate both sides, leaving ln of absolute value of h minus 20 equals negative 1 over 15 t plus c. Now I'm going to wait to figure out the constant c. Oftentimes people will try to find it here, but I'm just going to leave it for now. So next, I'm going to raise both sides to the e. So h ln of h minus 20, and then e to the negative 1 over 15t plus c. So on the left, the e and the ln cancel, leaving h minus 20. And I don't have to worry about the absolute value because, again, we know that h is between 20 and 75, making this a positive quantity. Now the c right here I can bring out in front as a different constant. And then getting h by itself, we have h equals ce to the negative t over 15 plus 20. Now, we'll plug in 0 for t, 75 in for h. So 75 equals c e to the 0 plus 20. So that leaves 55 equals c. So our particular solution is 55 e to the negative t over 15 plus 20.